All right, let me get you your note packet. This is notes for the next 3 lessons. And I'm going to have you start with fill work. There are 3 factoring problems to do. You may not need a calculator today. You can have one if you want. So you get it. You start factoring. If you lose this, I don't have extras, so you'll have to print it yourself. What? Stop. It's a loud one.
They got this to the joke.
This is confusing. I kind of got this.
I did something.
I can't tell you. You get stuck, move to be your seat.
I can't.
Every question today will have factoring. Every question tomorrow will have factoring. Every question Friday will have factoring. We have to factor. You can't give up on it. You'll have to factor 8 times in one question we do today.
Huh?
Yeah, so you better get over it.
Factoring was the only thing I retained from Algebra 1.
Factoring was the one thing I can't.
I understood factoring during Algebra 1. That was
I
3 years ago.
Did you do C?
I did B, I'm doing C.
Okay.
I think I did that.
Good.
I don't remember a single thing we did in Algebra 1. Like, I actually don't remember a single thing.
Didn't you guys take that like 8th grade?
Yeah, I don't remember.
That was our COVID year, so.
Hey, we need to be quiet. Not everybody's done. And this is very important.
Ask me for A. I got it.
All right. So I'm going to start with C. C is your most traditional type of factoring where there are 3 terms in what we call standard form, highest power to lowest. You want to think of what multiplies to W squared. The only thing could be a W times a W. 14 is different, so you can make your list if you need to or think through it. What 2 numbers could get me 5? A 2 and a 7. If the 7 is positive and the 2 is negative, I get 5W. They multiply to negative 14. Do I want to set those equal to 0 and get 2 and negative 7?
No.
That would be if the direction said solve or solve by factoring. If it just says factor, you just write the multiplication parts. So that will be typical of what we're doing today. If you can do C, you'll be pretty good shape. Sometimes there will be another number out here, like a 2 or 3, but not big numbers like 18 or 12. I think it'll be pretty quick factoring. B, if you choose, you could rewrite it like this. That could be fine. You probably dealt with this enough that you know the things that multiply to 64. Oh, it could be an 8 and an 8. If one's positive and one's negative, that would go away, which is why there's 0x. A positive times a negative is negative 64. If this said plus, would this work?
No,
Would this work?
no.
No, because then I would have 16 x's. Would this work?
No.
Yeah. Oh, no, it won't.
No.
Way to go, James. I would need this. That's what I would need. We are not doing a lot of that, but it could come up on the final or something else. So if there's a plus sign, you would do what you had before with the imaginary numbers. Jillian, what do you think for B?
Okay. Negative y times the quantity y minus 12.
Okay, so maybe you decided to write it in standard form first. That's a good idea to write your y squared, then your y. They both have a y in common, so I take that out. A lot of times we do take out a negative. That's optional. But if I take the y out, divide by a negative, it gives me y. Divide by a negative, gives me this. You didn't have to take out a negative if you just took out a y and left it like this. That is acceptable too. Just know at some time today, we will take out a negative.
I don't like this.
Huh?
I have a y of 6.
There's no equal sign. So you would just leave it with multiplication. All right, the title at the top, the very top that's underlined, says simplifying and solving rational expressions. That's this whole packet. Today specifically, 29.1, multiplying and dividing rational expressions. So what's a rational expression? Let's fill that in. A rational expression is an expression in which the numerator and denominator are polynomials. Talk briefly. What's a polynomial? A polynomial could be a monomial, could be a number, a variable, or the product of a number and a variable. This is a polynomial, one or more monomial. This is a trinomial or a polynomial. Poly is one or more monomials. Number one, simplify each expression. The second part we'll do when we're done. Make sure to check the restrictions on the variable. I'd like you to factor the top, the numerator, and factor the denominator, and then we can just stop for a second. There's no equal sign. We're not solving x is not 7. We are just simplifying this. Anybody see anything else I could do to simplify?
The x minus 2 is 2.
Yeah, this is on the top and this is on the bottom. Those cancel. So I have x plus 7 over x plus 2. That's pretty much my answer. I will have to, like it says, check to make sure the restrictions on the variable. So for example, this says any x's will work. Do you guys see an x that could cause a problem here? What number would cause a problem if x was that number? Negative 2. So write down, this is my answer, comma, or you don't have to put a comma, but we have to make sure that we say x cannot be negative 2. If it was, I'd be dividing by 0, and this problem wouldn't work. It works for all the other x's. Let's look here. Even though we crossed this out, it said x minus 2. What x would have caused a problem there? 2. Now, do I need to include that or not because it was crossed out? Well, let's see. If I plugged in 2 to the original. 2 squared minus 4 is, can I have that? No. So I also write x can't be 2. Even though that factor was crossed out, that answer of 2 into my original problem would cause a problem, so I can't have it. So you want to check your denominator and anything else that ever was a denominator. Yep.
So is that our asymptote?
We're not doing asymptotes. Let's go to C. Skip B, go to C. That's a ask me later question. I'm not trying to learn too much extra. Are these factoring ones you feel better about? Are these factoring ones you feel better about?
No, I hate all factoring.
Okay, so write down all things that multiply to 36. Unless you got a different way. You'll notice I sort of did it in 2 steps because my denominator has a GCF of x. I wrote that first, and then I was like, oh, that can factor further. If you can do this all at once, great. My numerator has a factor of x plus 2. My denominator has a factor of x plus 2. I don't see anything else that cancels, so I get an answer of x plus 18 over x minus 2. You'll notice I dropped the parentheses on the top because I don't need them anymore, but you could write them. Do these x's cancel?
No.
No, one is multiplied, one is added. The addition causes a problem. We do not cancel that. Please write down your restrictions. X cannot be. Why? How many restrictions do you have? Does anybody have 3? You got 3?
Will the 0 count or no?
Yes. Look at your denominators and look at what would give you 0. So I could set this equal to 0. X is 2. That would be a problem if x was 2. This would be 0. Set this equal to 0. Obviously, we don't always write all this down. -2 would be a problem. Set this equal to 0. No solving there, just 0. And it does look like 0 would be a problem. If I plugged in 0 for x, I definitely would be dividing by 0. So 3 x's that are not allowed. All right, so that's simplifying. Let's skip to E. Skip to E. Go ahead and get started on E as I do it up here. Again, I did the top in two parts. I factored out that x, and I factored it further. I decided to write my denominator in standard form. And then I looked to see what cancels, and nothing matches. These are all positive x's, and that's a negative x, so they don't have common factors. We could take a negative out of that, factor it out. If I divide by a negative, I get x. Divide by a negative, I get -3. I did not multiply by a negative. I did not divide by a negative. I didn't make it bigger or smaller. These are the exact same thing. I just wrote it differently. You are allowed to write it differently. You are not allowed to change the value. I didn't change the value. I didn't give it a negative or take it away. I just factored it out. Just like this. If I were to write 5x plus 10, these are the same thing. I didn't make it 5 bigger, 5 smaller. I just wrote it differently. Now, x minus 3 and x minus 3 cancel. What's this negative thing? Negative 1. It is okay to leave the -1 in the denominator. That's hardly ever how you'll see it in a textbook. Usually you'll see the negative in the numerator or out front. I would accept it in the denominator. Let's see if there are any restrictions. I don't see a denominator in my answer. Is there an x that would cause a problem? Yep. Lydia? 3 minus 0, that would be okay. So what number would cause a problem? 3, right? Yeah. If x was 3, the denominator would say 3 minus 3. Yeah. You can go back to the original. Sometimes we just go back to any denominators we ever had. Set this equal to 0. Set this equal to 0. Any of these denominators would still get you the same answer. We cannot have 3. All right. Questions? I can get you extra factoring practice if anybody wants it. So everybody feels like they're at the same pace. Number 2, not solve. Ooh, I did not say solve. I didn't mean to. Simplify each expression. Identify any restrictions on x. Factor the top and bottom of both fractions. Then you can stop for now. Figuring if you want some more time to factor, okay?
Is there gonna be graphs on this? We didn't.
The next one that says test. Oh, yeah, I just did a copy of it. Thanks. Yep, I did copy that. That's the one you're talking about? Thank you. I sort of did mine in 2 steps. Again, if there's a GCF, I just worry about that first. I don't try to factor several things at once. So here I noticed they have a 2 in common, so I just took the 2 out. It ended up that it did factor further, but I did that at the next step. Same for here. This has a GCF of X, and I took that out, and then I factored further. So let's talk about what might cancel. Do we think I can cancel this way over here and this way over here?
No.
Well, we have multiplication with this big dot here, but isn't there a dot here? And a dot here, and a dot here, and here, and here, and here, and here, and here? All of them are being multiplied, so it doesn't really matter where they're at. I could rewrite this. I could write the 2 first, the x plus 1, the x minus 2. I can write them in any order. They're all being multiplied as long as they stay on the top. Just like if I wrote this. Is that the same as?
No. Yes.
Yeah.
That's
If-
kind of trippy. Actually.
If I'm multiplying, I can do it in any order. I just need to keep them on the top. So it makes no difference if this is way over here and this is way over here. It's being multiplied on the top. It's being multiplied on the bottom. That will cancel to be 1. Same with this here, x plus 1 and x plus 1. And the other common factors in top and bottom. X minus 2, x minus 2. Questions? Write down any factors left in the numerator and in the denominator. You do not need to distribute them out. Just leave them like that.
Wait,
Go ahead.
wait, I want to
Go ahead.
So if like you have x plus 1 on the top and you cross it out twice, I know there's 2 x plus 1s on the bottom.
Yep.
But if there is only 1 x plus 1 on the bottom,
Just one would cancel.
just one.
Yep.
Okay.
So like if I had A times A times A times C over A times D, just the 1, and those would be left.
Thank you.
Go ahead and finish up the problem then by writing your x's that are not possible. Your denominators, even if they're crossed out. There are 4 of them.
I can't wait.
I'm just gonna go along this bottom row, even though things are crossed out, this would be -1, 1, 0, -1, which we've already written, and 2. If those values are the value for x, so 2 minus 2, that's 0, that would give you a 0 denominator, which are not allowed. So I write x cannot be -1, 1, 0, or 2. If you're not sure if that makes sense, plug it into the original problem. That'd be a lot of typing. And it would give you error message. Questions on multiplying? Okay, let's look at B. This is a division problem. Let's just start the same way we started multiplying. Factor the numerator and the denominator of both fractions. Be careful for the first one that you didn't do a 6 and a 1. Because you would have to do a 6 and a negative 1. And that won't give you a positive 6. It's got to be a 3 and a 2. If you want help with this one, this is the hardest factoring one we've had yet. We can talk about it. The first two terms have to multiply to 3. So 3 and 1 are the only things that multiply to 3. These have to multiply to 4. So either a 1 and a 4 or a 2 and a 2. So if I put a 1 and a 4, that makes 12x and 1x. That's never going to make negative 4. So I'll make this a 4. And make this a 1. That makes 3x and 4x. That's not going to work either. So I've tried 4 and 1. I'll try 2 and 2. That makes 6 x's. This makes 4 x's. And I need, oh, sorry, that makes 2 x's. And I need negative 4. So I would want this to be negative, this to be positive. It's okay if that factoring took you a little bit longer. Now, what did we learn about dividing fractions? There's a fancy saying you might have learned. 3 of you know? There we go, Allie. You got it. Keep change. Did I cut you up? Keep, change, flip? Flop. Okay. Keep, change, flip, flop. I didn't know I had the flop at the end. Yes. So we are going to keep this. I'm just going to rewrite it. Change the multiplication, and flip flop this fraction. Go ahead and do that. Keep, change, flip.
I have never heard flop.
I have not
I don't know.
either.
I probably added it. I
Probably.
think you definitely did. It sounds like though. I don't think so. Some paper with a flip flop on it. It was a paper with a flip flop.
Wow, look at that. I need to start adding pictures to my notes so you guys remember things.
That's true. It would help. I have like no room for the rest of this. Sorry. It's because I wrote really big on praise. So it's like kind of my fault.
If you keep, change, flip at the beginning, that's okay. You don't have to write out every step I do, but I like to write the division first. Once it's all factored, then keep, change, and flip. Is it okay to factor out or cancel, I should say, those two if they're far away?
Yes.
Yes. One is on the top being multiplied, one is on the bottom being multiplied. That's allowed. X plus 2 and x plus 2.
I don't know what that 5x is doing, but I'm not a fan of her.
Her. Why is it a her?
Because
Because odds are feminine and evens are plural? Whoa. Is that- odds are
Yes.
feminine and
Two
evens are
genders.
masculine.
Feminine and plural. Sorry, I had to think about it.
because
1 is, like everybody starts with 1, like when you first learn how to count, and the women come first.
Okay. I think I created Adam first.
Yeah.
I know.
What did I do?
All right, let's talk about restrictions. Write down what X cannot be.
I don't understand how we figure this out.
So look at every denominator. So my current denominator is this. I can't have this be 0, right?
Can't have 0 on
I
top.
can't divide by
Oh,
0.
yeah.
So I would say, okay, what X would turn this into 0? Negative 1/5 would turn this guy into 0. Can't have that. So that's one part.
What about before the flip?
Good question. Let's go through it down here first, and then we'll talk about that up there. So we've already taken care of what X would make that 0. The X's here would be 2 and negative 2. And then Mary said, what about before we flipped? These were denominators before they got flipped. I already took care of 2, so I don't have to worry about that one. What X would make that? Negative 2/3. And think about if you plugged in negative 2/3 to the original, if it would work or not. If I plugged in negative 2/3, it would make this 0. And I can't. So you are correct. You do have to check anything that ever was a denominator. Before the flip, after the flip, if it ever was a denominator, you gotta worry about it. Any of you ever played Salem? Once a witch, always a witch? No? Very fun strategy game.
Wouldn't there also be lots of
Yes, we just have that from
I
here,
see
right?
that, okay, yes.
So multiplying, dividing, not too bad if you can factor. Most of the factoring will be fairly easy compared to some of the factoring you've done before. Flip the page. We're not going to do more multiply and divide. I'll leave that for homework, but we are going to answer number 3. So it's a tiny bit of a thinking question. Read 3 and write your answer in standard form. Give it a minute. Read 3. Write your answer in standard form.
I don't have any work.
That's okay. You don't have to work, really. You have a final answer? What'd you put?
X squared minus 9.
I agree. If I cannot have 3, that would have come from that factor. If I can't have negative 3, that would have come from that factor. And in standard form, if my denominator is x squared minus 9, that would lead to those restrictions. Is this the only polynomial that has just these restrictions? Denominator.
No.
Correct. What's another polynomial that has those same ones?
Negative 9 plus 2, or plus x squared.
Yeah, it's kind of sort of the same. Good idea. Other polynomials that would have just those same restrictions for a denominator. One third what? Okay.
Well, I think x squared plus
Like
9.
1/3
The
x.
little I think. No, the little I.
Okay, wait, I have
Yeah.
2x squared minus 18.
That's the exact one I was going to come up with. 2x squared minus 18. This is a polynomial that would factor into 2. X squared minus 9, which factors into this. Does this have any extra restrictions?
No.
No. If it said x x plus 3, x minus 3. Then it would have a restriction of 0. But a number doesn't. Very good. All right, think about number 4 and write your answer if you can come up with one. If not, explain why. Mary, you could have done 1/3 x squared minus. Yeah, that was just a harder way to think about it.
Yeah.
Have we had any today with no restrictions?
I
No.
don't know.
Let's take a vote. Your votes are either no, it's not possible, yes, it's possible, or I need more time to think, I'm not sure.
I feel like,
Raise your hand. Nope, it is not possible.
I mean.
1, 2, 3, 4, 5, 6. Yes, it's possible. 1, 2, 3, 4, 5. I don't know. I need more time to think.
That's more where I'm at.
Yeah. So some people said it is possible. For those that said it is, did you come up with something? Because if you get an example, you're right. What do you think?
2.
2 doesn't really, it has a denominator of 1, but I see what you're going with, Jonathan.
4/3.
Wait, I was supposed to find
That's
a
okay.
fraction.
According
Wait,
to
there's
your
a straight
definition.
number?
I said it's
Oh,
okay.
fraction?
I just, not the one I want to
I
write.
just thought
Allie.
you had denominator.
I'm so lost. I heard a problem. Are they supposed to be numbers?
Yeah, their answers aren't wrong. I don't pick those to write because I want something a little
I
different.
put 2x plus 3 over 1.
I like that a little better. How about
Put it
this?
over, yeah, that's what I thought. I thought we were writing the denominator.
Yeah, technically any number over a number would work, but I want to see something a little more
That
descriptive.
makes
So
sense.
this has a denominator, but there's no way it's ever going to be 0. So here's an example. Technically, over 1 over 3 would work.
I was sitting there for so long and I was like, what can I set equal to 0 that would make it not 0? And I was like, it's not possible. There's no way I can do
Yeah.
that.
So we've been doing
Everything's
expressions.
just equal.
We have been, yeah, by the definition, yeah. I don't like that the definition of polynomial is 1 or more. I think it should be should be more than 1, but by the definition, polynomial is 1 or more. Yep, there's your homework.
No, I'm just gonna take a little picture.